Kens! Today we're going to learn about the very fundamentals of algebra and what the basics are all about. So, what is algebra all about? Algebra is all about finding the variable. A variable can be any symbol, as long as that symbol isn't a number. Conventionally, letters like X or Y, you've heard of them, they're used, or even Greek letters like theta, which you'll learn in higher maths. Some terms to know. An equation is a statement that two expressions are equal. There's a difference between an expression and an equation. The difference is that expressions don't have an equal sign, whereas equations do. Well, of course, right? Because equation sounds like equal sign. A solution is a value that makes the equation true. There can be multiple solutions to an equation, as will be seen in future videos. Inverse operations are two operations that undo each other. Maybe you've heard of them: addition, subtraction, multiplication, and division. Of course, there are two more that we'll talk about later. An example is addition and subtraction. If you add 5 to a number, n, and then you subtract 5 from the resulting expression, n plus 5, you cancel out the 5 that was added to n. This is a basic example of how we solve algebraic equations. Equivalent equations are equations that have the same solution. Once again, there can be multiple solutions to an equation. Take, for example, this equation: 2 plus 3 is equal to 5. Of course, this is a simple one. There will be more complex ones later on. Now, this is an equation because the two expressions, 2 plus 3 and 5, forgive my sloppy circles, have been equated using the equal sign. Now, you may be wondering, how is this 5 an expression? Well, an expression is anything, whether it's numbers or numbers plus variables, or anything that does not have an equal sign. So, some examples of expressions are 4 plus 3, or 3, or 2 times 4, or 6 squared, or 2x. These are examples of expressions. And so, if I replace the 3 with x, this now becomes an algebraic equation, because now there's an unknown variable right here. And if we want to solve this, you may be wondering that, yes, I did copy this and just made the 3 an x, so x has to be 3. And you would be correct, but equations are going to be much more complex than this in the future. So you can't just go, oh, I know that 2 plus 3 is equal to 5, and I'll just plug in 3 for x. You'll have to solve using inverse operations, which are a major factor in helping you solve equations in the future. Now, you may not have heard of equivalent equations. Don't worry, I never heard of equivalent equations until I looked into the textbook. Now, equivalent equations are basically two equations with the same solution. So, if I take this one here, 2 plus x is equal to 5, I need another equation that would have the same solution, x equals 3, to be equivalent. And an easy one would be 10 plus 5x equals 25. These two equations have the same solution, x equals 3, so they're equivalent. And if you look closer, you may have noticed that all I did was multiply this equation by 5. Well, it's a different equation, though, so they're still equivalent equations. So, how do you solve for x? As mentioned in the previous slide, you solve for x using inverse operations. This focuses on constants interacting with our variable. So if a constant is added to our variable, and it doesn't just need to be x, it can be y, it can be b. If a constant is added to x, you subtract that constant from both sides. And I'll come back to that both sides part. If a constant is subtracted from the variable, add the constant to both sides. If it's multiplied by the variable, divide the constant. And if x is divided by the constant, then multiply the constant. And if you do something to one side, you have to do it to the other side. Take this analogy, for example. Suppose this is you. Yes, you're a happy-go-lucky person, and you have a sibling. Now, if you do actually have a sibling in real life, you may notice that if your sibling gets something desirable, let's say in this case a phone, then obviously you'll want it too. It's the same with math. If something is being added to one side, you have to add it to the other. Now, in real life, it's obviously not the case when something's being taken away from your sibling, and I get that. But in math, that's not how it is. But there's a problem. How do you differentiate which side is which? How do you establish in math that you and your sibling are not the same person? Well, the separator is the equal sign. Let's take the previous example. If you were 2 plus x, if you were this expression, 2 plus x, and your sibling was the expression 5, then the equal sign would be what separates this side, 2 plus x, or you, from 5, or your sibling. So this signals to you that if you have the equation and you're trying to solve it using inverse operations, if you try to subtract 2 here from one side, you need to subtract it from 5 too, to keep it equal. Alright, let's try some examples. Let's take this first one. X plus 4 is equal to 14. Here I'm going to show you step by step how you're going to do this. You have to isolate this variable. This variable is what you want. If you get that variable by itself, you have solved the equation, and good for you. So you leave this variable alone and see what constants or numbers are interacting with this variable right here. And you're only looking at the left side. You're ignoring the right side for now. So we can see that this 4 here, it's being added to our variable, x. What we want to do is remove that 4 and move it here. But how are we going to do that? Because there's this equal sign over here. Well, we're going to use the inverse operation, subtraction. We need to subtract the same amount from this whole side so that the 4 cancels out and moves to this side instead. So what we do is we subtract 4 from the expression x plus 4. And what you do to one side, you need to do it to the other side. Because if you want to move it to this side, you need to do it to both sides. So we need to subtract 4 from here too. And this results in x equaling 14 minus 4. See how the 4 moved to this side? Now we have x by itself. Now you can simplify this and you'll get x equals 10, which is our solution. Of course, you can always check. If this is correct, our equation up here will be true. But how do you check? Well, you use the 10 that you got, you use your solution and plug it in for x. So if our solution here is 10, then we put it in x. So 10, and then we write the rest of the equation. Plus 4 is equal to 14. Now, is that equation true? Well, we do know that 10 plus 4 does equal 14, and 14 equals 14. So, we're all good, and 10 is our solution. Now, let's try the second one. Y minus 7 is equal to negative 3. Now, yes, you have seen the negative, and I'm assuming you know how to manage with negative numbers, for they should have been taught. So, we leave our variable alone, y. And remember, a variable can be anything as long as it's not a number. It just needs to symbolize that there's an unknown there. It can vary. And we see what is interacting on this side. What is interacting with our variable? We can see that this 7 is being subtracted from y. You can also say that negative 7 is being added to y, but I think that would be a little confusing for you guys. Because, let's see, if you try to do y plus negative 7 is equal to negative 3, yeah, you can do it, but it's going to be a lot more complex than needed. So let's erase that. Okay, let's go back to this. So what you need to do now is use the inverse operation. And what is the inverse operation of subtraction? Addition. Remember, addition and subtraction are inverses of each other. So if something's being added in here, we subtract. If something's being subtracted, we add. So we need to add 7 to this whole side. And what you do to one side, you do to the other. So we need to add 7 to this side too. This gives us y equals negative 3 plus 7. And that is equal to 4. And if we want to check this, you need to plug in the 4 for y. So 4 minus 7 is equal to negative 3. Is this true? 4 minus 7 does equal negative 3, and negative 3 equals negative 3. So this too is correct. Alright, let's solve equations using multiplication and division now. So we have 2c is equal to 16. Now we leave this variable alone. And I encourage you to pause this video right now and try these two out. See how you do. Alright, I am assuming that you're done and you've gotten an answer, and now you're waiting for me to check with you. We leave this variable alone, and we can see that this 2 here is being multiplied by c. Now, if you're not familiar with this format, it may be a little confusing, but 2c is the same as 2 times c, 2 times c, and 2 times c. Now, we tend to avoid this one because, of course, if the variable was x, you can see how that's confusing. So we tend not to use this as the multiplication sign. Instead, we use the dot or parentheses. Any of those work. Or this one. This one is obviously the least complex. So what we need to do is use the inverse operation of multiplication. And what is that? Division. So we need to divide this whole side, 2c, by 2. And what this does is it cancels out these 2's, so it leaves the c alone. But in order to keep it equal, we need to do this to the other side too. So we need to divide 16 by 2. And this gives us c equaling 16 divided by 2, which can be simplified to c equals 8. And we can check that using our plug-in method. Plug in 8 for c, and we get 8 times 2. Or you could do 2 times 8. You can do that. Is equal to 16. Well, is that true? Well, yes it is. So we are good. And c does equal 8. Now, if you're not familiar with this format here, you may find this much harder than this or other ones. But in fact, if you are familiar with the fraction symbol signifying division, then this should be a piece of cake. So we see that k divided by 7 is equal to 5. If you don't get this format, it's the same as k divided by 7 is equal to 5, but we're not going to see this division symbol very often anymore, because in algebra we tend to use the fraction symbol because it's easier, it's more compact, and it may be less confusing. So you need to get used to it. And so we have k divided by 7 is equal to 5, and I'll just use this one here. If something is dividing, then we multiply by that constant. So we need to multiply this whole side. Forgive my parentheses, I was a little bit squished. We need to multiply the whole side by 7, because what this results in is 7k divided by 7, which obviously equals k, because these 7's cancel out. So if we multiply by the whole thing, then the 7's cancel out and we get our k by itself. But what you do to one side, you have to do to the other side. So we need to multiply 5 by 7 too. And we get k equals 5 times 7, which is equal to 35. And let's check our answer. Plug in 35 for k. So 35 divided by 7 is equal to 5. And that's true. So 5 is equal to 5, and we're good. Thanks for watching. If this helped you or you liked this video, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions relating to this topic, put those in the comments below. You can also answer any questions that you have the answers to. If you have any suggestions as to how I can improve my videos, or even suggestions on what I should do next, put those in the comments below. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one.